Yeah, so again, thank you everyone for joining. We're very glad to be able to help host the Lumiata Hackathon. I think a lot of what we bring to the table is we make it very easy for you to build production-ready data projects. And a lot of how we do that is through data pipelining. So I know that in most hackathons, that are only 24, 48 hours, building something production-ready is usually out of the picture. But we're very glad that Lumiata has made it part of their theme for this hackathon to actually build something that is production ready. And we hope to help you all get to that point. So from here on, I'm gonna start sharing my screen. All right, great. So hopefully everybody can see my screen here. So essentially what we have here is the Ascend UI for our COVID-19.ascend.io environment. So this is an environment full of data sets, data pipelines that we've actually gone and built out for the general public to use in order to help fight COVID-19 with more data-driven decisions. So I'm sure most of you know this already, but you can access this just by going to ascend.io/COVID-19. Filling out this quick little form here will actually automatically bring you into the environment right here. So when you log in, I'm currently logged in with my personal email. You should see something a little bit like this, where you have two data services, which are sort of just organizational groupings of data pipelines and data sets. One is the COVID-19 data vault. So this is where all of the data sets that we found across the web will exist and will be exposed to you. So obviously you can go into any of these and take a quick look. We have some from Johns Hopkins. We have some data from Snowflake. AWS and GCP have also released theirs, with GCP, a lot of it being BigQuery, and AWS putting all of theirs into a public data lake. Ooh, let me log back in here. I think my session was a little long. All right, great. And then you'll have your own personal data service. So this is where you can actually go and import any of the data from your data vault and actually go forth and do your own analysis of those public data sets. So a lot of what we really help with is, usually data can be scattered across a lot of different data sources. And so in this example here, what I'm doing is I'm taking the case data from Johns Hopkins University, and essentially they've given us a data set with all the global cases reported on an hourly or daily frequency, and then all the US testing information. So this is all of the relative COVID-19 tests grouped at a state level, updated daily. And my goal here is I want to join it and then see if there is some sort of a relationship that I can understand between the two. So first, bringing these data feeds in is as simple as going up here and going to data feed connect, and this will bring up essentially a data catalog. So a little bit more about what a data feed is. A data feed is essentially a pub sub for a data set where you say, this data set that I've just been working on is really nice. I would like to share it with a lot of other people so that they could also use it in their own sort of collaborative environment for whatever sort of data science, data analysis, data exploration that they want to do. So over here, you can see everything from our COVID-19 data vault. We currently have 13 different data sets that are published here, and we plan on adding quite a lot more as we continue to find more and more relevant data sets, so whether that be related to symptomatic responses, research papers, et cetera, et cetera. And if you would like to add anything to that public data vault too, feel free to just ping me on Slack once you have something built and we can review it together. Yeah, so going on over here, I've essentially brought in two sorts of data feeds. Like I mentioned, the JHU data and this US testing data, which actually comes from AWS. So the first thing that I want to do is I want to normalize this data in the same sort of way. So obviously the big difference is that this one is grouped by state and updated daily. The JHU one is not necessarily updated daily. It's more updated on a more push basis, where whenever there's new data, they will update it. And like I mentioned before, this is all global data. So essentially what I have here is I have a group of transformations related to data cleansing and getting this data to a point where it's ready to join with the testing data. So the first thing that I do here is I wrote a little bit of SQL that is casting the last update column to a date type. Then I went and grouped it by day and by province. And I believe I also filtered it to just be US here too. And then finally, I wrote a little bit of Python that would essentially map the state names over to their state abbreviations. Because it's one little thing that you might notice here, which is that when the data comes in from JHU, the province state column is in this sort of long form format, while the AWS format is more in this sort of 2-letter code format. And so once everything is all prepared, I'm able to join it very, very quickly and very simply using some basic SQL here. So going into a little bit more about these transformations, Ascend is a data engineering platform. So what we focus on is data movement and data pipelining. So this can mean moving data from point A to point B, but having multiple different sorts of steps in between, ultimately creating a sort of DAG where going left to right, you can see the data lineage and the data evolution over time. So any of these red components, which are known as transforms, you're able to view what the data looks like at that stage. And then you're also able to look at some of the metadata. This will give you some of the range statistics around each column and then how long it took to process and stuff like that. Yeah, so end to end, essentially what we've done here is we've brought in a couple of different data sources. We've normalized one of them and then ultimately joined it here, where now at the very end, we have both testing data and case data in the same place. So this is really nice and really powerful when you want to do model training or some sort of evaluation based off of more features and more labels that you wouldn't be able to find in a single data set. So I'm gonna take a quick pause here and just say, are there any questions? Is there anything specific that people want to dive a little deeper into? Jove, is there anything you'd also like to add? Or anything that I may have missed?
No, I think I will love to see if there's any questions since we have been going on for a while.
Looks like we have a little message.
All clear?
All clear, cool. All right, so we'll keep on moving forward. I'm gonna talk a little bit more about the platform and then how you can read data off the platform, which will be more important as you continue to build your hacks, whether it be in a notebook, in more of an application or something like that. So in Ascend itself, what we've shown you is the graph view of a data flow, which is the best place to see everything end to end, actually work with the data, make edits and stuff like that. There's a couple more views that I want to talk about. The first one being timeline. So the timeline view is an easy way just to see how stuff processes end to end. And this is really nice when you want to see, how long did something take, what happened after it, and stuff like that. So one of the parts that makes this a production-ready pipeline is essentially whenever the downstream data source changes or updates with new data, that data automatically propagates end to end through the rest of your data flow. So you don't actually have to worry about rerunning anything or reprocessing anything. All of that will happen automatically for you. So all of these data feeds are connected to a data source that have their update frequencies already set based off of the type of data source that it is. So this will usually update every day at midnight or every week, depending on the actual data source that's there. So this becomes really nice because then you don't have to worry about actually figuring out how to productionize your data project after the hackathon is over or even towards the end of the hackathon. And then the last type of view I want to talk about is our query view. So this is a function that we have called queryable data flows, where you're actually able to run SQL queries against any stage within your data pipeline. And this is also a great way to interactively build your pipeline and develop upon it as you go. And as your teams continue to grow, and hopefully, as you have more and more people, this becomes a great way where you can actually share some of the analysis and views that you get into your data just by running SQL itself. So what you can see here is I've actually, another user here has run a SQL query over this data set, and this was actually later converted to a transform, but you can see that it was shared here, which is why I have access to it and stuff like that. Yeah, and then so this also brings me to my next topic, which is, once you have all of this data, automatically moving through your pipeline, and Ascend is managing all of that, and you reach this point where, I'm ready to do, some sort of machine learning or some sort of analysis over the data itself. How do I actually connect Ascend to my actual data project? And so I'm going to demo some of those integrations here. One is obviously we allow you to export data locally at any point within the pipeline itself, either through this query view right here, or if you go back to the graph and you click on any of these components and you go back to the records view, you'll be able to find the same export button here. So this is probably the more generic old school way of being able to connect data out. But there's another more programmatic way. So all of these components will have a little handshake button here, which is our data integrations. So this integrations tab will show you a couple of the different ways that you can read data off of the component itself. And what I'm going to focus on today is the Python SDK, mainly because that will probably be more familiar to all the data scientists and data engineers out there who are working in Jupyter notebooks or Python-based applications. So what I've done is I've actually gone ahead and built this Jupyter notebook beforehand, and this is going to show a little bit about our record streaming API, which is the ability to stream data off of Ascend at any stage within the pipeline. And if you want to dive a little bit further into the code and the documentation behind this, you can find the documentation at developer.ascend.io, which is our documentation page, which you can also find through our main web page. And you'll also be able to find a link to the SDK, which is public, so you will be able to easily access this. So before you stream anything to your notebook, you have to make sure you install this with a quick pip install. Very easy, very quick. Yes, so going back here, we try to make our SDK as simple as possible, mimicking our organizational layers of a data service, a data flow, and then ultimately a component. And then to set up the actual SDK itself, the first thing that you need to define is just what host are you connecting to. So this is essentially your Ascend environment. And in this case, it will be Covid-19.ascend.io, which is public, so you all will have access to it, of course. The next part is credentials, obviously. So we want to be able to identify, who you are and figure out exactly what sort of components you have access to inside of Ascend. And so the easiest way to do this is through creating developer access keys for yourself. So if you go to the top right, you'll be able to find this access keys tab underneath your profile. So if you hit show, there will be this little button right here where you'll be able to click it, and essentially you'll be able to get an access key ID and a secret access key, very similar to AWS. So make sure you copy the secret access key because this is the only opportunity you'll have to see it. After this window closes, you won't be able to see it again. And I'm actually going to go ahead and delete mine in case any of you, attempt to use it since this is being recorded. Yeah, so once you have that configuration set up, one way to just directly use this with Ascend is you import our Ascend client, which is going to be your main touch point from the SDK. And then you just pass in the 3 required parameters, which is the host, which like I mentioned before is just covid19.ascend.io, the access key ID, and the secret access key. Essentially what I've done here is I'm just reading from a local file, send credentials, and it's formatted like this. So this is a more secure way to do it if you'd like, but obviously if you're just doing some sort of experimentation and you're not publishing or putting this file into GitHub, this is also a very simple way to get this done. So the client itself is pretty powerful, and you can definitely find some more information about it in our documentation. But it's a great way for you to essentially be able to browse Ascend programmatically. So in this case, I'm listing all the data feeds that I currently have access to. And as you can see here, this is all the data feeds from COVID-19 Data Vault, which is the exact same view that I just showed here. But to read data, essentially what we need to get to is we need to get to one of these Ascend components. So it's either a data feed, a read connector, a transform, or a write connector. So in this case, if we go back to my example of me being a data scientist who's just joined JHU data and US testing data, I would really like to be able to ultimately just work with this joined data set right here. So it'd be really, really awesome if I could get this into my Jupyter notebook. So essentially the configuration that I need to pass here to build this transform in Python is these three variables, which is the data service, the data flow, and the component ID. And like I said before, you can find all of this in our documentation itself. And so where I get these strings from is actually in the URL for each component, where the organization corresponds to the data service, the project corresponds to the data flow, and in this case, the view is my component, which is US testing and cases. So I'm able to just copy and paste all of these over to my notebook, and essentially, let me go ahead and run all of this for you. So I'm gonna run all above. Cool. And then if I run this, should be able to see, yep, so the data just got passed in. I'm doing just a little bit of pandas magic right here. So I read it into a pandas data frame. This is essentially all the code that you need to stream that data off of Ascend and into whatever sort of application or notebook you're currently working in. And then everything else from here is just more basic data sciencey stuff. So I read it into a pandas data frame, I set the index, I sort it, and then I show the tail, so the last 10 records. And then a quick example of something you can do with this data is essentially what I did here is I plotted the confirmed cases, and this is actually the cumulative number of people who are hospitalized. And I'm doing this for New York in this graph. So you can actually see since around April 10th, April 11th, the number of people who are hospitalized in New York is slowly starting to decrease, even though the cases is still continuing to increase approximately linearly. And I then went ahead and did the same for California. So pretty much just only changing this query right here. And you can see in California, it's pretty interesting. We actually have less cases compared to the number of people hospitalized, although there is some interesting blips going on over here. And it does look like for the past couple days, the slope of the number of confirmed cases has been increasing a little bit, which is a little worrisome, but who knows, got to keep our eyes on this. Yeah, so that's ultimately end-to-end, a very quick example of how you can use Ascend to join different kinds of data sets, and an example of some of our data sets that we've published for you, and then ultimately how you can directly integrate it into whatever sort of application you end up building for the hackathon. So the example I showed here is just basic data visualization, but I'm sure as many of you well know, once you get to this point, it's very easy to do some sort of downstream like TensorFlow training or other sort of sophisticated analysis as you'd like. And the cool part here is that, like I said before, this is all production ready. So this data flow will automatically update itself with new data once it comes in. And then, every morning, if I reran this notebook, I would automatically be able to see the new data without having to change any sort of configuration, without having to trigger any sort of pipelining job or anything like that. Yeah, so that's pretty much it. We are about, at the 30-minute mark of this workshop itself. That's the main part of what I wanted to show is the fact that, if you're able to build your data pipelining in Ascend first, you don't have to worry about integrating your project with any sort of production-ready tool once it is complete. As always, feel the best way to reach out when you have issues is either over Slack or with this little intercom button down here, and you'll be able to reach me or Jove within minutes or seconds if you use either of those tools. Yeah, so that's pretty much it for the demo itself. I'm going to open this up for any Q&A.
Yeah, I have a question about importing files. I see that there is like several options, and let's say if I have a CSV that's a URL, right now when I import it through this data flow, it's sort of, it's static. It doesn't upload from the latest URL. I have to upload the CSV file itself. Is there a better way of doing this?
Yes, that's a great question, actually. So what the question is referring to is building your own connectors first, right? So we have our connector library here. And then to be able to read through file upload, we have this local file upload connector. So this is a great way to link local files to Ascend itself. But like what the question referenced, what happens if I have a CSV file behind a URL that updates, daily, weekly, or hourly, or even minutely? The best thing to do here is use our custom read connectors, which is a more programmatic way to connect a data source with Ascend. And I'm actually going to go through an example that we have here in our COVID-19 data vault. I believe, yes. So this University of Washington data is COVID-19 cases with symptoms. And essentially you can see the type of this read connector is a function type. Unlike some of our other data flows like AWS, where the type is S3. So with a function type of connector, essentially what this is doing is this is using basic Python just to connect to the data itself. So what you can see here is that this URL, which might be very similar to the URL mentioned in the question, ultimately links to a CSV, latest data.csv. And essentially what we're doing here is we're going ahead and using these three functions to describe how that data should be read into Ascend. So context, this is if you have some sort of credentials related to the URL that you need to use. Obviously, in this case, we don't have any, so we just return an empty dictionary. The list objects one is if you have a huge amount of data that needs to be partitioned in some sort of way, this is where you would define partitions here. For most of the cases that we've seen in this hackathon, you don't really need to partition your data. So in this case, just following an example like this is tends to be recommended, where in this case, we're essentially giving it some arbitrary name, a fingerprint, and then we set this to false, even though you actually don't need to set that. But ultimately, the meat of this comes in this read bytes function right here, where you can see essentially what we're using is we're using the request library to make a get call to this URL. And this will actually give us the CSV payload in the response content. So to quickly show what that looks like, this data itself, it might take a while to load since it is pretty big. Essentially, it's just a huge CSV dump. And so ultimately, the read bytes function is allowing you to connect the result of that huge CSV dump to Ascend itself. And then once that data is in the parser aspect of the connector, you can select the XSV format, which will work for a CSV because the field delimiter will just be a comma, and then the schema will be populated for you. And you can see in this case, this data has some stuff related to symptoms, hospital admission dates, et cetera, et cetera, et cetera. And then ultimately, why this is better than a file upload is this refresh schedule configuration right here. So like I said, how we would be checking for new data automatically. This is very similar setup to a cron job, where you just set up a regular frequency for Ascend to go and check that third-party data source, has my data changed? Is there any new data that I need to read in and propagate throughout Ascend itself? I hope that answers your question.
Yeah, wonderful. Thank you.
Yes, and of course, I know that some of this code can be a little bit difficult to write by yourself, so feel free to ping me or Jove if you run into any issues with that. Great, any other questions?
Can I ask the second question?
Yes, yes, of course.
Okay. Yeah, so I'm trying to share this with my team members. So, we don't want to duplicate the data flows. So what's a good way of sharing it?
Yeah, great question. The way that we currently have COVID-19 set up is that each user will get their own data service. With that data service, every single data service comes with its own teams, permissions, and members. So the members functionality here will allow you to invite additional members to your data service itself. So if you hit invite new members, you can put their user email here, their username, and the permissions level that you want to invite them as. Really, member, it's no permissions. We usually recommend either read only if you don't want them to touch anything. User admin won't actually be able to edit any of the components. Data admin will be able to, but it won't be able to invite other users. And super admin is, full access. So they will be able to invite other users and also add data and add and edit data components. So this part is, where we usually recommend you to share your data service and enable collaboration. Obviously, if you run into any issues here, this environment is a little bit special because we've made it publicly available. Feel free to ping us. We can help you debug that. And maybe also just set up something for you and your team rather than an individual data service for your email. Cool. Okay. Any other questions? Okay. Sounds like there's no other questions. I wasn't expecting too many, mainly because questions tend to come up as you continue to build inside of Ascend itself. And so like I mentioned before, this workshop is mainly just an example of showing you one way you can use Ascend to join data and read it off into whatever sort of Jupyter notebook you're using. But obviously there's many other ways for you to integrate with your application and also many other ways for you to bring data in and transform it in Ascend itself. So like I mentioned before, feel free to reach out to me or Jove over the Lumiata Hackathon Slack when you run into questions or through the intercom button like I mentioned before. These are all great ways for you to get in touch with us and get your issues resolved very quickly. Yeah, Jove, anything to add before we end the workshop?
No, that's it.
All
Thanks
right.
a lot, everybody.
Great. Yeah. Thank you, everyone, for attending. We'll give you back an extra 20 minutes of your quarantine lives. Looking forward to seeing all the cool data projects that you all build. And yeah, looking forward to be able to help you out at any step along the way. Great. Thank you.
Thank you.